All right, so this lesson is just reviewing graphing straight lines, or straight lines are also called linear equations in math. So from IM1, if you remember, there's three types of straight lines. There is a line, a horizontal line, a line that is vertical, and a line that has a slope, which is diagonal. Okay, now just reviewing what slope means. The word slope kind of in English means, is there a steepness to a line? It means a lot more in depth in Mathanese. Slope is the rise over run, how vertical or how horizontal it is getting. But let's just keep it super simple right now. For right now, whenever you hear the word slope, it's asking, how steep is it? So we have to give a number that represents how steep it is. But before I talk to you about the numbers, or this is once again from IM1, you should have remembered a line like this. Is there a steepness to this line? If I put a marble on this line, would a marble fall off it? No. There is no steepness. So how do we represent a number that has no value? We would say it has a slope of 0. That means this line has a slope of 0. There's 0 slope to it. Nothing's going to fall off of this. And just a refresher from IM1, these kind of lines, they're called horizontal lines. And horizontal lines are lines that start like this. Y equals just some number. Any number here would represent a line as long as there is no x in the equation. So for example, y equals 5, or y equals -5, or y equals -50, or y equals 503. It doesn't matter what this number is. As long as there is no x next to this and it's just a y equals, that means you're going to have a horizontal line straight across. Okay, now the next type of line that you should have learned from IM1 was a vertical line. The question is there a steepness to this line? Yeah, there is definitely a steepness, but I have no idea what it is. Meaning there is in Mathanese, when we can't create a number that goes up and down, it's called an undefined. This line is undefined. The slope is undefined. I mean, we can't find a number to represent the slope. So lines like this, they're the opposite of this. This has no slope. This has an undefined slope. And it's always just x equals whatever this number is. I'm going to show you how to graph these in a second. But for the sake of this course, vertical lines have an undefined slope and it's x equals any number. As long as there's not a y next to this. X equals 3, x equals -3, x equals 30, x equals 341. Whatever this number is, as long as it is an x line, it's an undefined slope. And the most common lines are like this. This has a slope. This has a slope. And I'm going to be talking to you guys about slope in a second. But this slope is a positive, meaning it's a positive number because we're going up and over, up and over, up and over. Any line that's going up, think of like a mountain. As you go uphill, it's a positive slope. As you're going downhill, meaning you're going down, it's a negative slope. And when you are at the top of the mountain, it's a 0 slope. So this is a positive slope because you're going up. Think of going up a mountain. And then think of going down a mountain. This right here is a negative slope. So just reviewing again, kind of what I just said. See if you can pause the video and if you can remember each one of these, what the slope is. Pause it right now, stare at this, figure out what each one is, and then unpause it and then see if you got it right. Okay, so if you just pause the video, this line has a slope of 0 because there is no slope to it. It's flat. This line, there is a slope, but in math we call vertical lines undefined. This is an undefined slope. This has any kind of a negative slope, and this is a positive slope. So if you paused the video and you came back to this, each one of these, this is the answer. Okay, next I'm going to talk to you about an equation of a line. There's two types of equations of lines. Well, there's more than two, but for this course right now, we're going to be talking about two types. We're going to be talking about the slope-intercept, slope-intercept. And this is on your notes as well. Slope-intercept is y equals mx plus b. Now this might look a little crazy, but your m is your slope. This is your slope. This is your y-intercept. This is from last year again. This is no new IM2 concepts. This should look familiar to you. Your slope tells you how steep it is. And your y-intercept tells you where it crosses the y-axis. So for example, let's say we had an easy graph like this. Y equals 2x plus 3. And I say graph this. What you're doing is you're always plotting your y-intercept first. So let's take a graph right here. My y-intercept, where it crosses my y-axis, is 3. Here's your y-axis from last year from Math 1. This is your y-axis. So we would go up 1, 2, 3. And we put a point there. Now my next step is my slope. Always make this slope a fraction. If it's 2, make it 2 over 1. If it's not a fraction, just make it a fraction by putting a 1. And the way this works is this. You always go up this many spaces. In your denominator, you always go over to the right this many spaces. So 2 over 1. My first step is I plot my 3 on my y-intercept. My second step is I plot my slope. So my slope is 2 over 1. So I'm going to go from here, I'm going to go up 2 units over 1 to the right. Up 2 units over 1 to the right. And if I continue that pattern, this is what that line would look like. Now I'm going to put a couple more examples up here, and then we're going to work through these. I'm going to have you guys graph a couple more examples. All right, so for this next one right here, I have 3 different equations. Here's the first one, second one, and third one. What I'm going to see if you guys can do right now is pause this video and see if you remember how to graph this. This is your y-intercept, this is your slope. Pause it and see if you can graph it. Okay, now that you paused the video and you're coming back, to graph this involves 2 steps, and I'm just going to do all these graphs right here. My first step is you should have graphed -1. And then your second step is, if this isn't a fraction, make this 4 a fraction. Put it 4 over 1. And then from -1, you're going to plot this. Remember, you go up or down. If this is a positive, you go up. If this is a negative number, like this is going to be in a second, you go down. But you always go to the right, this number. So from here, I'm going to go up 4. 1, 2, 3, 4, but then over 1 unit to the right. And then I'm going to continue this pattern infinitely. 1, 2, 3, 4, over 1 to the right. And then there is my line for that. So that's what your line should look like. Okay, pause the video and see if you can do this one now. Okay, now, after you unpause it, let's see if you got this one. Let's see if you got this one right. So I'm gonna go. I'm gonna plot my y-intercept, but you should have noticed there is no y-intercept. Well, actually, there is. There is a y-intercept. It's just your number is plus 0. Because if there's 0, technically 0 doesn't even exist, so it doesn't have to be there. But in terms of plotting, this is my first step. Plot your y-intercept, which is 0. It's in the origin. That's where the 0 is on the y-axis. Now what you're going to do is you're going to plot your slope. You're going to go from here, you're going to go down at this number because this is a negative. You go down 1, 2, 3, 4, 5, but you always go to the right, this number. You're going to go 1, 2 to the right, down 5, over 2. If you continue this infinitely, you're going to get a line that looks like that. That's that graph right there. Now pause it and try this last one, 3/4 x plus 5. All right, now that you paused it and tried it, let's see if your graph lines up to what this is. Okay, so my first step you should have done is, if you graph 5, you're going to go 5 on the y-axis right here. That's the first step. And then my second step is, this is already a fraction, so I don't need to make it a fraction. I'm going to go up 3 because this is a positive fraction. If this is a negative fraction, you're going to go down 3, but you always go over to the right 4. Just makes it easier. Go up 3, 1, 2, 3 over 4. 1, 2, 3, 4. Boom. And then if you were to continue this pattern, it would look like this. This is going to be kind of what your line looks like, just like that. Okay, now the next two that I'm going to give you are the weird one. It's the x graph and the y graph. So I'm going to pause this and write these two equations up for you to try and graph these. Okay, so now the next sets of graphs that we're going to do is x and y graphs. Remember, x lines are going to be up and down. They're vertical. There's an undefined slope. The y graphs are going to be horizontal. There's a 0 slope to this. Let's start off with this. This is the easiest way to graph these. This tells you what axis you start on. X-axis at 4. Here's my x-axis. I'm going to go over 4. And x lines go straight up and down, so from the 4 goes straight up and down, and it's that simple. There's an x equals 4 graph. This is my y line. Notice when there's no x, it's not y equals mx plus b, it's just y equals a number. Whenever it's just y equals a number, start on this axis and go to this point. -3 on the y-axis. Y lines are horizontal, so make it horizontal. There is your y line. This is x equals 4. This is y equals -3. Super simple. Okay, now the last type of graph that we're going to do is, we're going to talk about this a little more in depth later on, but from review from IM1, you had graphs called graphs in standard form. Now what I'm going to do right now, I'm not going to go too far in depth in standard form. What standard form looks like is this: 4x minus 2y equals 8. This is standard form. When you have coefficients next to your x and y and just a constant number on the other side of the equal sign, it's called standard form. Or in English, what I just said, because what I just said was in Mathanese. In English, when you have both of the x's and y's on one side and the other number on the other, it's called standard form. It's going to ask you to graph this. Now, the way that I would suggest that you do this is get the y all by itself. So just use basic algebra, isolating a variable to get this y all by itself. So the first step is move this 4x to the other side. How do you move a positive 4x? You subtract the 4x from both sides. And this is going to give you negative 2y equals negative 4x plus that 8, because this is a positive 8. You can't subtract 8 from 4x because they're not like terms, so you just write, I had a negative 4x and then I had a positive 8. Now, the next step that we're going to do is get the y all by itself, so just divide everything by negative 2, and then clean it up. Negative 2 divides by negative 2, these cancel out, and I get y equals negative 4 divides by negative 2, a positive 2 times. But there's that x there. And then you have 8 divided by negative 2, which is negative 4. Here is your equation in slope-intercept form. And then you could graph it. This is your y-intercept, this is your slope. I'm going to put one up here, and I'm going to see if you guys can try this now. Let's try, let's say 5x minus 15y equals 30. Let's do negative 5x minus 15y equals 30. My question to you is, write this in slope-intercept form, something like this, y equals 2x minus 4. Change this to look like this and then graph it. Pause the video, change it and graph it, and see if it works what I'm going to do. So try that now. Okay, now that you just tried it, you just pause the video. Let's see if your thing came out exactly like mine. First step is you got to get this negative 15y all by itself by adding 5x to move this over to the other side. Well, the good thing is these cancel out, so you're going to get negative 15y equals this 5x. You can't add that to that 30, so we're just going to say I have a 5x and a positive 30. Okay. The next step that I'm going to do is I got to get my y all by itself. So you should have looked at this and said, okay, I have to divide everything by negative 15. I have to divide every single thing by negative 15 to get that all by itself. To get y equals 5 divided by negative 15. Even though the negative's on the bottom, we're just going to make it a negative fraction. And then 5 and 15 becomes 1 and 3. 5 divides by 5 once. 15 divides by 5 3 times. With that x, let's get a little more room here. Now 30 divides by negative 15, negative 2 times. And this is the slope-intercept form of this graph in standard form. So we got the y all by itself to get it in slope-intercept form. Now we can graph this. Here's your y-intercept. It's at negative 2. So here's my graph. I go down 2. And then my slope is negative 1 over 3. So once again, you're going to go down 1 because it's a negative 1, but then you go to the right 3. Down 1 over 1, 2, 3. Boop! That's exactly what your graph is going to look like. So the assignment that you're going to do today is the worksheet that's attached to the calendar. So go ahead and do the worksheet. The answers are attached to the calendar as well.